Okay, welcome to this lab. Lab's going to be a packet spoofing and packet sniffing lab. Um, so for this lab, I'm actually running two virtual machines, an attacker and another one that's called a server. The first thing you need to do for this lab is install Scapy, and in order to install Scapy, you actually need to download pipe. So just type this command in. And since I already installed, this program is not going to do anything for me, but now in order to install, once you run that, in order to install Scapy, you'll do sudo pip3 install Scapy, okay? And then it'll install it. So the reason we actually are using Scapy, it's a packet sniffer just like Wireshark, but the only thing different is that it can be integrated into a Python program. And like Wireshark, which is just a application and graphical interface. So the first thing that we're going to actually do for this lab is we're going to run the sniffer in order to be able to pick up any ping addresses. So I've already written it before, so I'll show you. So what I'm doing here is actually creating it to run a subnet, but I'll show you how to do that later. So we'll do filter is equal to, and in open quotes, ICMP, and this is actually going to filter only ICMP packets. And writing the program, you can see here I have from -user-bin python 3 from scapy.all imports. It's going to be able to import the sniffer tools, and then just copy all this. You're defining this function, and then here's the filter, which is going to be ICMP. We're going to change that, and then again, in order to run Scapy, you have to make it root privilege the application. So we're going to do chmod a plus x, and then task 1.1. There you go. Now we're going to run it. So we'll do sudo python 3, and then task 1.v1. There we go. So it's sniffing packets, and then I'll open another terminal, and I'm actually going to be able to ping. So I'm going to ping actually my VM, which is a server. And you should go back to here, and you should see the following: IP version 4, protocol is ICMP, your source and destination. So what this actually is, it's showing us the reply. And if we go a little bit up, right down here, this is the requests that you're sending. So this is the ping request, and down here will be the ping reply. So once you're done with that, we'll Control C, and we're actually going to do the same thing, but just modify the program in order to get TCP packets. So we'll just do and we'll do TCP and destination port 23 and source host, which is my host, and then we'll just write and quit, and again compile it, and then we'll run it, and then I'm actually going to go to the second terminal window and do telnet.10.0.2.7 and type in seed, the password, Perfect. I'm in. Exit it. And then as you can see, here we go. We are in. The protocol is a TCP, and it's actually showing you the source and the destination wherever you telnet it to, the source port and the destination port, which is telnet. And then another thing that I'm going to show you is actually the program that you can do to sniff out specific subnets. So we'll go to task 1.1p1, and this is going to be a little different than the destination, the IP. We're just going to write destination net, short for subnet, and we'll do 104.17.96.0-24. So it's going to scan from 104.0.0.1 all the way to 104.255.255.254. And you know the drill, compile it, and run it. It's a sniffing packet, so we'll just go here and we'll ping a random address. So the address that I'll ping will be 104.17.96.9, and it's pinging, and as you can see, there it goes, source and destination. Because again, we decided to do any filters from a subnet, so it'll filter any IP addresses, any ping requests and echoes from the subnet 104.0.0.1 all the way to 104.255.255.254. So we'll just exit this out. We'll clear this program. The next step that I'm going to show you is actually going to be using Wireshark. So what I'll do is I'm actually going to do sudo python just to get the Python terminal. And like the other codes, I'm going to do scapy.all import asterisk. And then a is equal to an IP, a.source, which will be my destination, is 10.0.2.7. B is saying that this is an ICMP protocol. And then P, we're just going to do this, A divided by B. Now, before you send the packet, we'll close that. We'll open Wireshark, and I've already opened it. And as you can see, this is the network where it's on. So we'll just open that. It's already scanning, so send P, send packet. We can also do LSA, and it can show you the source IP field, destination IP field, and so on. But the thing that we want is actually here in Wireshark. It's showing us that we sent a ping request to our source address and our destination address, and it replied back here. So that's how Wireshark works and how that program works. So we'll just exit out. Now what we can actually also do is we're going to spoof our source IP address. So just wanted you to double check here. Our source is 10.0.2.6, which is the IP of my attacker VM. So if we go here, it's this. What we're going to do is we're going to spoof the source IP address to be whatever we want. It doesn't even have to be a live computer. So we'll do the program again, sudo python from scapy.all import, right? And now we're going to do A again is equal to IP ICMP. A dot source is going to be 10.0.0.2. Now, whatever IP address that you decide, I'm going to actually do 4 since none of my computers are up. I messed up. Let's go delete that. There we go. Perfect. Now we're going to do a dot destination is equal to 10.0.2.7, which is the other IP address. Sorry, I cannot type today. And again, we're going to send an ICMP packet, and then A divided by B. And now we're going to send P, but I'm just going to make sure it's recording. There we go. Sent one packet. Perfect. Now let's look. So here it didn't reply. So let's try and do this another way. Let's exit out. And let me clear everything out, and let's do sudo python. Okay, from space scapy dot all import star, and then a is equal to ip a dot source is equal to 10.0.2.3. I'm going to change that. And then a dot dst destination is 10.0.2.7. And then b is equal to ICMP. P is equal to a divided by b. Send. Let's try this again. Send P. Packet sent. Perfect. Now let's see what we got. So yeah, you see source IP field and destination IP field. Perfect. So let's go to our Wireshark. And aha, here we go. So I'm sending this spoofed IP address to the real IP address of my server, and my server actually replied to it. So as stated, this IP address is not existent within my network or even any virtual machines that I have turned on, which is just 2. So that's how you spoof an IP address in a ping request. Now, we can also do with the traceout function. So what I'm going to do is I'm going to clear everything out and show you the program that I wrote. So it seems like I might not have it here. Let's see, I think it might be this program, sorry. Nope. Okay, so we'll just write it. It's not such a big deal. So we'll do VI, and I'll just name this trace out. So trace out. Oh, sorry, here it is. I figured it out. It's actually VI. So sorry about that, guys. So what we're gonna do is actually we can do ns lookup, and I'm gonna do, let's do google.com. So I have the IP address right here for Google. Now, just so you know, finding an IP address, trace routing, and pinging is completely legal. So you can do it anytime you want, as long as your purpose is good. So I'll run this program that I've had, ttl.py, which is time to live. This is an IP address of before that I've written. So what I'm going to do is I'm going to delete that. I'm gonna paste this, and the time to live is actually just how many hops it has for a trace route, and I'm gonna actually just put 4 here, and we'll see what happens. And again, we're actually going to use Wireshark for this program because it's sending a ping request. So we'll do sudo chmod a plus x ttl. Perfect. And then let me double check something. So it's Python. Okay. So now we'll run Wireshark also. And we'll run this program sudo python ttl.py. Sent 1 packet, perfect. And let's see. So as you can see, it actually, what does it say? Sorry, when you make the window bigger, it actually takes a really long time. Here we go, and let's do info. And let's see what it says here. So it says time to live has been exceeded, which means the 4 hops is actually longer than it actually takes. So let's maybe try and do 1 hop, and we'll see what that goes into. Interesting. So you can see, like, here it actually says that this has not been exceeded, so it hasn't even replied. So let's actually try and use Traceroute to see how many hops it takes. So we'll do Traceroute. Where is it? The IP. Let's do clear. And let's look up www.google.com. Okay, so Traceroute 172.217.7.196. So the reason for this part is it's just getting lost. But you can see here that it's actually sending out the ICMP. So let's just try this program with another IP address that I've written, which is my school's IP address. So we'll do 129.174.1.59, and the package will be 9. Let's clean all that. Sudo chmod a plus x. Why can I not type? There you go. So there was no reply from it. Let's try let's actually clear this up a bit, because let's try that again. See, so there's no reply, so it's actually sending it, but it's not getting, no response is seen. So let's try maybe making it a little bigger. So we'll make the time to live, I'll make it actually, let's do, I'll do 15 just to see. And here it is. You see the response. It responded from here to there. Even though it exceeded, the time to live exceeded. But this is what you want, because it responded to us. So that's how you would use a this program to actually figure out how many hops it takes for your computer to send out that ping packet all the way to the IP address. So we're actually going to use another program, and it's going to be called a sniffer. So we'll actually run this program here. So we'll clear this and we'll change to desktop. There we go. So we are gonna do vi sniffer dot. Nope. So we'll do vi sniffer dot py. And again, I'm only filtering ICMP packets. So let's run this again. We'll run sudo. Hold on. Let me check Python. Okay. So we'll do sudo Python and sniffer.py. Sniffing packets, perfect. And then we'll run the TTL program. There we go. And there we go, echo request. So you can see here, destination, it was requesting, time exceeded, which means, this part right here replied to us, as said previously. So this is just another way that you can show you the packets changing. So now what we're going to do next is actually we're going to clear all of this. And we're going to actually write a program that will sniff and spoof packets at the same time. So for this, you're actually going to need your two VMs up and running if you haven't been doing that already. So what I'm going to do is I'm going to get on my server VM, which is this one. And sorry for the screen being a little small and not being able to see. I'll fix that. There we go. Perfect. So we'll open terminal. And what I'm actually going to do is, to show you better, I'm going to run this third VM, which is my VM3 user / observer, basically a client, and we'll run it. So just to explain to you what we're going to be doing actually is we're going to ping on our client's machine, this machine right here. And then once we actually have confirmation that the VM is up and running, we are going to turn it off and run our machine that is supposed to spoof that IP address. So we'll do ping den.0.2.8. Hopefully it's running. Yes, as you can see here, it is on and running. Okay, perfect. So that's what we want. So we'll go to our attacker VM right here, and we're actually going to run the program called Sniff and Spoof. This one right here, Sniff and Spoof. So vi sniff and spoof. Okay, so what's going to happen is it's going to send an ICMP packet, and these print statements are just little print statements that is going to show you the original packet that's being sent and then the spoofed packet that's being received. So our source host is 10.0.2.7, and it's going to be an ICMP packet. Okay, so let's gonna actually run this VM, right? And we'll turn it off now. Perfect. And again, don't forget to, once you compile this code right here, vi sniff and spoof. There we go. So once we run, all this code right here is going to be provided in the network security textbook, or if not, by the professor. And what this is actually going to be running on our attacker VM, it's going to see that the source host is trying to ping the VM that we just shut off. And this program is going to be actually sending the packet back. So let's run it. So we're going to do sudo python sniff and spoof py. We'll run to our second VM and we'll ping again .0.2.8. And this is what the magic is right here. We are getting replies back from this ping even though the machine is turned off, which is what you want. This program is supposed to work if the machine is on and the machine is off. And as you can see here, it says the original packet was sent from this destination, from this source to this destination, and the spoofed packet was sent from destination of the computer turned off to the source packet. And that's basically how this program is running. So once you get this thing, then you know it's definitely working. So another thing that we can do is actually write a sniffer program. So let's just escape this and control. We'll clear this out, and we're going to use actually PCAP. And another thing that you need to know about using PCAP is that you have to be in root. So we're going to switch our user to root because again, PCAP, it is a sniffer and it has to be in root privilege. Or you can just make the program root privileges as well. I just think it's easier for me just to switch into root root user. So what we're going to do is actually we're going to write the following code, which is, I'm calling it sniff. So yeah. So which is sniff.c. So vi sniff.c. And this program was actually given to us by, again, in the folder that I've showed you. And it's gonna again open a live PCAP session. This part you'll need to change though, which is gonna be your network. I changed it to this. And it's gonna capture packets, and it's pretty much self-explanatory, this code, since it's already written out for you. And let me do switch user root. There we go. So now what we're actually going to do is run the program. And open your second terminal. We'll right quit. And we'll ping our server VM. Perfect. And there we go. So it says it got a packet from our source to that and it also got a packet from, which is a respond packet. So this is basically how our sniffer is working. It captures packets when are being sent. So the thing that would happen, so let's say you turned off your promiscuous mode. In this part of the lab, the promiscuous mode is actually going to be this line of code right here. If you just comment it out, you're going to get an error segmentation fault. The reason why how I know this was the promiscuous mode was here because your promiscuous mode is a part of the chip in your NIC card, which is within your computer. Now, if you turn that on, then you'll be able to sniff packets. If that's off, then you won't be able to sniff packets at all. So it's important that if you do, that is turned on. Some computers, their chips, their NICs might not have it. So we just something to keep a close eye on. So now what we're going to do is we're actually going to capture ping packets from two different hosts. So again, I'm going to be using my attacker and my server virtual machine. And we're going to actually use this program. Again, they're all given to us. And it's this one. So we're going to do vi sniff v1.c just so you can see the program. And it's going to be just getting ICMP packets. And the only thing that I've changed was my host and my destination. And obviously my network card. And that's pretty much all you have to change. So we'll just go back. And again, make sure to compile this program. Since I'm in root, it's already compiled. And I'm going to run it. So sniff b1. And go to my second terminal and ping my server VM. Perfect. Go back here, and it shows you the protocol that the packet was captured. If you remembered in the previous lot in here, there's no protocol, but here there is. It's showing you that it's an ICMP, which is what you want. We're gonna do now. We're gonna modify this and run a TCP packet. Wait, so we're gonna do. I'm gonna show you. It's this program right here that's going to be capturing TCP packets. It's the same program, just again changed a couple things. So we're going to do sniff b2.c. And the thing that was changed was this part right here, that we're doing the protocol TCP and the destination port range is between 10 to 100. And again, you can change, this is completely changed, but this part right here is important if you want to be capturing TCP packets. So we'll close this out, and we're going to actually run this program. So we'll do dash sniff v2, go to my second terminal, and I'm going to do a telnet 10.0.2.7. Let's see, there we go, exit, and again, here you go. So it's showing you the from the destination to my host, what my source port was and what my destination port was, and that the protocol was TCP. So this is one way that PCAP actually is helpful. It's just showing you the protocol number, the source and destination, and what the ports are. So now another thing that we're going to be able to do is we're going to use PCAP in order to capture passwords. So this is a little more tricky, but it's doable. So the program is sniff c.c. So vi sniff c.c. And this program again was given to you. same thing. Protocol is the same as before. So now what we're gonna actually do is, one thing I forgot to actually mention is whenever you're compiling this program, you have to be definitely in root user, not just have to be in root privilege. Uh, the reason why is because you're going to be using your compiler is going to be this, that, let's say sniff c.c. We'll do sniff c and then sniff c.c. But the key thing to add with any PCAP program is this right here. This little add-on is what makes you have to be in root user, because if you're not in root user, then it's not gonna work. So just remember that when you compile all your programs, if that's an issue you're having. Sorry, I forgot to mention it. But now we'll run this program. So the program I actually changed the name to is called Sniff Password, because it's what we're trying to do. So we'll do this sniff password, and we'll go to our second terminal, and we'll do telnet, and we'll do again oops, well, it's not gonna work since I messed up, but let's try that again. Perfect. So I'm in. Let me quit this because I don't need this. Okay, so let's exit, and now here you go. So now in order to find the actual um, password, the password's D's, DEES. You'll look at these lines right here, and it's a little challenging because you have to find it's the last letter. So it did not pick it up on this one, so we'll just try again. There you go. So I'm in. So now we keep looking. Here's an S, an E, another E, and there's a D. So right here, here's your password, DEES, and that's how you will, and that's how you sniff the password out. So we'll actually go here, and I'm gonna exit, so just I don't get confused, and I'm gonna clear everything. Now what we're gonna do is we're actually gonna use a tool called Socket and your C program. This is how you're gonna be able to spoof ICMP packets. Now, the thing with raw socket is that what it does is actually gives you more control to design your spoof, your sniffing and spoofed packet. So you can just have in general more control of it. So the program that I'm actually using, and I'll show you, is the following program. Let's see if I can find it. So let's see, where is it? Here it is. It's called, so we'll do vi icmp spoof.c. So the program is written out for you already. The thing that I changed was actually I changed the source IP address and my destination IP address. So the source IP address is just some random IP address that's not even within my network, and then obviously my server VM. So You can read through this, and it's just the comments show you what each process of the code does. But I'm actually gonna open Wireshark as well, and we're gonna run this program, and I'm gonna show you how it's gonna do it. So it says here, sending spoofed IP packet from this to this. Now let's go to Wireshark, and as you can see, it's sent from here, from my spoofed IP source to my destination, and it actually replied. So that's how that program's actually going to work. And again, don't forget, we're using PCAP, so again, don't forget to compile using -l PCAP, okay? So now that's mostly all the labs that deals with the packet spoofing and sniffing. What we're going to do now is run, I'm going to actually close this since this is not needed. We're going to be using Nmap, just going to show you how to use Nmap to do a port scanner. So we're actually going to exit from root privilege since that's not needed for most things. So the thing that I'm going to do first is just going to be a simple port scanning tool. So we'll do Nmap, and we'll do -s and then P, so it stands for scanning protocols, and we'll do my IP. We'll do the subnet, so it's everything in my subnet. And as you can see, it only shows 3 machines just because I turned off my server VM. But if I want to, I can actually I'll turn it on again just to show you. Let that run. And then let's try and see. Once it's on, then I'll definitely do another port scan. Okay, yeah, it's on. I just saw it down in the window. So let's run the code again. So basically, here you go. You see it says the host is up. So you could technically change this 6 into a 0. It really doesn't matter. It's still going to scan from 10.0.0.1 to 10.255.255.254. And if you're not familiar, the reason why I don't include the last 255, and it's because it's actually a broadcast subnet or an address, which will mean that any computer that 255.255.255 is reserved for broadcasting purposes. And then the 10.0.0.0 is actually reserved for your router for a gateway. That's why you always start with .1 and end with .254. So enough of this networking stuff. So that's how that Nmap works. Another thing that we can do is we can rank the IPs from lowest to highest or highest to lowest. So we'll do Nmap -sp like before, 10.0.2.6-24 pipe the AWK, and then we'll open parentheses dash Nmap scan report. That, and we'll do that. Print number $5. We'll close it. Close that. Perfect. And now it's running. And here you go. Again, from lowest to highest. That's how it prints it out. All the IPs in your network. Now we're gonna run a port scan for TCP. So in order, you'll run nmap -st scan, and we'll use this website that's actually given to us by in the lab assignments.org, which you can scan. I strongly don't recommend scanning Google or anything like that, just because they might see it and might think, oh, it's phishing, and think you're trying to attack them. But this website is fine. And as you can see, it's actually showing us the port 22 is open, HTTP is open, and all these are open except for this one. So this website is actually behind a firewall, which means that what ports like SMTP are filtered. When it says either closed or filtered, you know that Nmap just can't get anything out of their scan. Now we'll do a TCP SYN scan. So we'll just do nmap -s big S and then scan me dot nmap.org. And you see, we weren't expecting this because it requires root privilege, which is okay. We'll just switch. Okay, and let's run the command again. Now, one thing you should know is this is actually going to take a really, not really long time, but it actually does take time. So we'll let this run, and we'll come back to it. We'll actually move on to the next step for lab. And the next step of our lab is we're actually going to be scanning machines that are behind the firewall, like as stated before. So we'll just switch root again. Well, for this one, actually, you don't need root. So we'll just do nmap -st, and then we'll use this website. So they're both actually going to take a good time to return an output. Just because it needs the power and it's a more in-depth scan. So what I'm going to do is I'm just going to turn this off since I don't need it at the moment. And I'm going to let these scans run. As you can see, my battery's actually going to die, so I'm charging this computer. Perfect. And keeps running. Quit. Don't need that. So I'll just let that run. It'll take some time. And I'll show you the other things that we can do. So what I'll do is actually I'll show you the one stuff that Nmap can also do, which is look at packets. So we'll open another terminal, and we really don't have to be in the desktop or in any folder, but I'm gonna do nmap --packet trace, and then we'll do -s big S scan me .nmap.org, and we're gonna write this into a file, and the file is out. Before it was called trace.out, but I'll change the name to trace2.out. Okay. Again, so there you go, root privilege. So there we go. Now, so let's run this again. Nmap packet.trace. See, so it says here successful, success. So let's just Control C, and then we'll clear all this out, and we'll do trace.out. So we'll do vi. We can do cat trace2.out, and here is all the information from the packets that were saved, or every packet that was saved. Let's see. So this is just something cool. So I'll just remove the trace.2 out. We don't need it anymore. And then let me check this. Here we go. So as you can see here, I'm actually, once this scan returned, it showed that this port is actually closed. If it doesn't say close, it'll say filter, but we know that this port, they closed this port down. Now another thing is you can see the reason why the port is closed. So the command we're actually going to use is nmap. I'm going to switch to root just so I don't have any trouble. Let's clear that. Switch user root. There we go. Perfect. So now we'll do nmap -- reason. So again, it's going to take a little time just to run. And then this is also taking a little bit of time to run. So we'll just go here and we'll do another step, and we'll come back to those. So Nmap can also return the OS, traceroute, and device version. And in order just to get that, you'll hit the following command. And it's going to send out a huge report, so it's initializing the stealth scan. While that's running, let's hopefully see if this is still running. So basically, I mean, this is taking just a long time, probably just because I have the Windows, so I'm just gonna cancel it. And the output of this has to be, it's gonna be just giving you all these different ports. Some of the ports will be obviously the SSH, domain, HTTP, nping echo, and the it's called elite, which is port 31337. Now the thing that's not going to show is actually the SMTP port. So just remember that when you're running this command. I'm just going to close it out, close this terminal out. And as you can see, when we run the reason for why this port was closed, it says connection refused. Obviously, we know it's behind the firewall, but that's another way that just a way if you're curious to see why it refused, why it says closed. Okay. Now, here you can see the program is still running, or it should be. Just Control C. It's still running. That's why. So we can just let that keep running. So I'll just let that run. And then, so what I'm going to do is we can actually do a UDP scan. Now, UDP is takes a lot more time than TCP. So we'll do nmap-v-su for UDP. So scanning UDP and scanme.nmap.org. It shouldn't take that long on this VM just because there's not that many virtual IP addresses running. But we can still let it run. This, on the other hand, should be, there we go. So control, let's see. So basically, again, it's ran. It shows you here's a version that we were talking about that we wanted to run. And it also gives you more information. The title, go ahead and scan me, what server's running, trying to figure it out. So sadly, I actually closed it out, but you can get a lot of information from there just looking around. It can shows you the ping, the trace route, all that within that program itself. So we'll just close this terminal because we don't need it. And here's actually what we wanted. So all 1000 scan ports on Scammy are open and or filtered. And so this is what you're going to get when you run a UDP scan. And that's pretty much the whole conclusion of the lab, which is the packet spoofing and sniffing lab. I hope you actually learned some things, and I do apologize for some things not working or skipping over. But I'll see you on the next lab video.